Hello students, in this video we shall start learning mean value theorems. There are three mean value theorems: Rolle's theorem and Lagrange mean value theorem, and one more is Cauchy's mean value theorem. But in this video we are going to study two theorems, Rolle's theorem and mean value theorem. These two theorems are there for your syllabus. First, let me discuss what is the Rolle's theorem. Okay, in order to define these mean value theorems, we consider the domain as the interval like this. Okay, interval, closed interval a comma b means these two are the two end points. Within those two, any number of points may be there. So the function f is defined between that range. For example, in trigonometry you have studied sin x function is defined between -1, 1. Between -1, 1 means what? The values of sin x will not exceed 1 or will not be less than -1. Within -1 to 1 those values will be like that. I can define a function f on the closed interval AB and its range being any real number. It may be any real number, f from A, B to R. Suppose it is continuous in the closed interval AB. Continuous means there is a flow like this. There is no any break. Suppose I have for some values A to C like this. After C it goes up to B like this, means the function is discontinuous at this point. Okay, it should not happen in continuity. Suppose f from AB to R is continuous within that closed interval AB and the function f is differentiable in an open interval AB. Sometimes it may become infinite at the end points A and B, but within A to B, okay, the derivative should exist finitely. Okay, and in addition to these two, if f of A is equal to f of B, if the values of these two endpoints are equal, then okay, if all these three conditions are satisfied, then there exists one point C, okay, where it is within the interval AB. There exists at least one point C belonging to the closed interval AB. C belonging to the closed interval AB. Within A to B, there exists a point C. For example, here I took -1, 1. Within that, I may take 0, okay, or 0.5 or -0.5 like that. Okay, such that the derivative of the function f of x with respect to x at C becomes equal to 0. So how you read this one? Let f from A to B be a continuous function in the closed interval AB. It is differentiable in an open interval AB. Then there exists, suppose f of A is equal to f of B, then there exists an element C within the interval A to B such that derivative of f of x with respect to x at that point C. As usual, you will differentiate this with respect to x. You will get f dash x. Wherever there is x, you will put some points in C. F dash C becomes equal to 0. Where that C is, C should lie between the range A to B. If all these three conditions are satisfied, then there exists a point C at which the derivative is 0. Now, you look at the geometrical meaning of this one. Now, I will show you the graph. See here. Suppose for sin x you have seen. How is the graph? The graph used to be like this. Suppose I define the function f of x between these 2 points, A comma B, A to B. Okay, the curve, suppose it bends like this. It is bending means what? The function, there is a flow means it is continuous. Its derivative may also exist. And now A, its f of A is this value. Okay. Suppose I have one more point, say A1, its image will be f of A1 here. Suppose I have A2, its image will be f of A2. There is a point C means its image is f of C here. So this point will be C comma f of C. Like that. And after that, suppose I have a point after C. If I take a C1, C2 or any point, its corresponding value is here, like that. At the end, for this last end point B, we have the value as f of B. And you are observing here, f of A is equal to f of B. In case this happens, then there exists at least one point on this interval. There exists at least one point between A to B, there is a point C here. How this point C is, this C, its value f of C, its derivative with respect to x at that point is 0. Whenever the derivative becomes 0, dy by dx equal to 0. What that dy by dx indicates? Slope of a curve. Dy by dx is equal to 0 means slope of the tangent drawn to that curve at a particular point becomes equal to 0. Once the slope becomes equal to 0, how that line will be? That line will be parallel to the x-axis. So, what is the geometric meaning of Rolle's theorem? In case f of x is continuous in the closed interval AB and differentiable in an open interval AB, then in addition to that, f of A is equal to f of B. F of A is equal to f of B, right? So thus, if all these three conditions are satisfied, then there exists a point C within the interval A to B such that the tangent drawn to that point on the curve at a particular point is always parallel to the x-axis. In the second figure also you see, our function is defined between A to B. Okay. Now, A comma f of A will be this point. Now we have B. B comma f of B will be this point. This means f of A is equal to f of B. All the three conditions for Rolle's theorem are satisfied. Now there exists a point C. There exists a point C within this interval A to B. How is that point C? The tangent drawn to that point C, okay, is parallel to the x-axis. This is our x-axis, so it is parallel to the x-axis. Got it? I hope you have understood. Now, similarly, you can see there is a curve like this. So, between A to B, f of A is equal to f of B here. Both the endpoints, you can see, both have the same values. Is it not? Now, there exist 2 points here. There is a point C1 at which the tangent drawn is parallel to x-axis. There is a point C2 at which the tangent drawn is parallel to x-axis. Thus, I use the word, then there exists at least one point. Okay, if a function is defined in the closed interval AB is continuous and differentiable in the interval A to B, then in case f of A is equal to f of B, then there exists at least one point at which the tangent drawn is parallel to the x-axis. It is more clear from these figures. Okay, I hope you have understood. Now, let me define Lagrange mean value theorem, or it is also called as just mean value theorem. It is similar to Rolle's theorem, but in Rolle's theorem you will put three conditions. Let f from AB to R be a continuous function, and let f from AB to R be a differentiable function. And in addition to that, third condition is f of A is equal to f of B. Okay, but here in Lagrange's mean value theorem, only first two conditions we consider. Let f from AB to R. AB means what? The function is defined on an interval. Okay, and that too, if I use the bracket like this, it indicates closed interval. Let f from AB to R be continuous in the closed interval AB and differentiable in an open interval AB. Differentiable means you will take the function as it is. Suppose you have considered the function as say f of x is equal to sin x. You will differentiate. It will get it as cos x. Okay, then you will look at the range that x should be lying between the range AB to R, A to B. If for all values between A to B, if this exists finitely, then I can say f is differentiable in that interval. Okay, it is not compulsorily differentiable at the end points. At the end point, sometimes it may become infinity, but within A to B, it should be existing finitely. Once these two conditions are satisfied, then there exists one point say C within the open interval AB. Within this point A to B, there exists a point C such that how that C will be? That is f dash C is the ratio of f of B minus f of A, f of B minus f of A divided by B minus A. In our Rolle's theorem, what happened? F of B is equal to f of A. Once f of A is equal to f of B, f dash C becomes equal to 0. This is it not? So, the Rolle's theorem is the specific part of Lagrange mean value theorem. In a Lagrange mean value theorem only, in case f of a becomes equal to f of b, it goes to the statement for Rolle's theorem. Now, here f of a is not equal to f of b, but what I can say is f dash c, there exists a point at which, okay, if you differentiate the curve and put the value c, that answer is always equal to the ratio of the range values to the difference in the range values to the difference in the domain values. Okay. This also will be more clear by this curve. I told f of a is not equal to f of b. The curve will not bend like this, or it will not go like this. Whenever it is in U shape or inverted U shape, it stands for Rolle's theorem. Now, I have the curve like this. This is our curve. A, from A to B, it is defined like this. There is a point A. What will be its image? Its image will be along the y-axis. This point will be F at A. Okay. Now, another end point is B. What its image will be? It will be F at B. So, what this point will be? It is B, comma, F of B. Now, F, our function f is defined between a to b, closed interval a to b, and if it is differentiable in an open interval a to b, then there exists at least one point. I have a, for on this curve, you can note this curve. I have drawn like this. For this curve, if you draw a tangent at some particular point, there exists a point C. The tangent drawn at that point C is parallel to the line joining A f of A and B f of B. I hope you understood. Suppose the curve is like this, then it is A and this is, I will take like this, f of B. Then if you join these two, there is a line drawn, there is a tangent drawn at some particular point which is exactly parallel to this line. We call this line joining A comma f of A and B comma f of B as secant drawn to the curve, and this line is called as the tangent drawn to the curve. So, let me tell you what is the geometric interpretation of mean value theorem. Suppose f is continuous in the closed interval AB, differentiable in an open interval AB, then there exists at least one point such that the tangent drawn at that point is parallel to the secant. Secant means what? Is the line joining A f of A and B f of B. Okay, this suppose these two are the two end points, A f of A and B f of B. Our curve is moving like this. Our curve is moving like this. Then in between that there may be a point C such that the tangent drawn at that point C is always parallel to the secant joining A f of A and B f of B. This is the, I have taken one more figure for Lagrange mean value theorem. A, its image is f at A. B, its image is f at B. If you join f of A and f of B, it is called as the secant. Now, our curve is moving like this. Then, in case it is continuous in the closed interval AB and differentiable in open interval AB, then there exists a line which is parallel to this one, and it is the tangent for that curve. There exists one point like that. Okay, so that point, how you will call it as? It is f dash C. F dash C is f of B minus f of A divided by B minus A. This is how we define these two theorems. Okay, in the next video, we shall see the examples on the Rolle's theorem. I hope you have understood by heart the formulae. Thank you.